All right, welcome back. So now let's get into the notes for this section. And all we're going to look at is, again, the division property, which we started last video with, as far as looking at when to apply it, when not to apply it. And then also we're going to talk a little bit more about the excluded values, because the excluded values do kind of change as we are looking at different rational expressions. So just a quick reminder, again, going through this division property, any number, term, or expression, when divided by itself, is going to be equal to 1, okay? A lot of times, students or even teachers will use the word cancel out, but that's not really true. It's actually just being divided by itself, all right? And a lot of times this gets confusing when we have like addition here, but you can see that these two expressions, right, are exactly the same in the numerator and denominator, and this term up here is separated by multiplication. So again, here I have 4 divided by 4. We can just cancel those out, and that's going to equal 8. And again, you could simplify this, right? 32 over 4, which also equals 8. So it doesn't matter if we have x's in here, guys. It's going to be the same thing. A lot of times we just use this line, and that's why I think students get this like cancel out idea. But in reality, x divided by x one time, 32 divides into 4, or 4 divides into 32, 8 times, okay? So again, it doesn't matter if it's a number, if it's a monomial, or if you have like a binomial or a trinomial or whatever it is, as long as you have that expression is the same in the numerator and denominator, and there's not separated by any other expressions with addition or subtraction. So in this case, that is going to divide the 1. And then obviously the big thing that we looked at is here, a lot of students will do not do this, divide these out and say that equals to, x. Right? We cannot do that. So what we want to do is when we have terms that are separated by addition and subtraction, we're going to want to factor them out. And actually, I'm not sure. Oh yeah, I think I was just trying to make a point here. So you can have those terms factored by addition and subtraction, and then here, actually, nothing would go ahead and divide out. So a lot of times we just want to make sure we're not making that nothing here divides out, so we just leave it as is. Okay. Now let's go ahead and get into the excluded values. So again, the excluded values is going to go directly to what we talked about with the identifying the asymptotes and the wholes. And we will be continuing on that. But for this section, we're just going to focus on the algebraic idea, right? Just focus on simplifying the rational expressions and then just reminding ourselves that, whatever our denominator cannot equal 0. So finding the values that make our denominator equal to 0. So that's important because the excluded values are the values that make the denominator 0. All right, so that's it. That's all we're focused on. So we're not focused right now on anything in the numerator, right? We're not doing the domain or anything like that. We're just looking for values that are excluded in this rational expression. So therefore, in this case, we're just going to set our denominator equal to 0. So, oops. So in this case, we have x equals 3/2. Here, we're not worried if things divide out or if they don't divide out. We're just focused on setting the denominator equal to 0 and solving, because those are the values that are going to make the denominator equal to 0. So x cannot equal 3/2, right? X is not defined in the domain, okay? So we can just say x cannot equal, well, x equals 3/2, but our excluded values, I should probably say, is a lot of times we'll write, in the simplified version, we just say x cannot equal 3/2. In this case, we'd have 2x squared plus 2x minus 4 equals 0. Notice I can factor out a 2. X squared plus x minus 2. All right, and then equals 0. Now in this case, be careful because you can still factor this out. This is going to be an x plus 2 times x minus 1 equals 0. And again, when we're solving this, remember 0 product problem, we don't care about the scalar, right? So we're just going to set x plus 2 equal to 0 and x minus 1 equal to 0. So therefore, x equals -2 and x equals 1. So there'd be 2 excluded values when x equals -2 and x equals 1. I didn't have to do anything with this 2 because that was a scalar, all right? The next one here, if I had 1 minus x cubed equals 0, notice that this is, if you remember, this is the cube root function. If you remember, the cube root function has 1 real, right, and then 2 imaginary. Well, we don't have to worry about the imaginary solutions. Those aren't going to be excluded, right? We won't exclude imaginary solutions. So all I'm simply going to do is just be worried about the x cubed minus 1 equals 0. Okay, and then again, this negative is not really going to, that's just reflection. It's not going to change the zeros, so I can just divide that out, right? So all I did was I factored out the negative and I rearranged my terms. So I have x cubed minus 1 equals 0. the only real solution, if you guys recall, is going to be x minus 1 times a x squared, and then let's see, that's going to be a the plus the a times b, so plus x and then plus 1. Okay, and that's going to be imaginary solutions. So my only solution here is going to be x equals 1. All right, now what happens? Now let's look at the operation. So for simplifying rational expressions, it's fairly simple. Just whatever your denominator is, set it equal to 0 and solve. Those are going to be your excluded values. It doesn't matter if they get divided out or not. When you're just trying to find excluded values, you're setting the denominator equal to 0. Obviously, if it's an asymptote or whole, like it makes a difference if it gets divided out or not. Now, when we're looking for multiple expressions, we need to do this for every single one. Now, in this case, I recognize that this is a I don't know if I was planning on doing that or not. I don't know. In this case, you can see that we have some values that we want to go ahead and simplify. So in this case, I could simplify this to x plus 3 times x minus 2. This is already an x minus 2. And then this could be x minus 2 and x plus 2. Okay. Now, again, when you're dealing with multiple denominators, whatever makes the denominator equal to 0 is going to be excluded. So we're going to say the values that would be excluded is, a lot of times we write x cannot equal negative 3, positive 2, and negative 2, right? So that's what I'll kind of go back up to here. I just want to say like x cannot equal 3/2. X cannot equal negative 2 and negative or positive 1. So, whatever the simplified version is, x cannot equal 1. All we're looking for is, if I'm going to add and subtract, whatever I'm going to do here, no matter what my final answer is, I just want to make sure that x cannot be defined for negative 3, 2, and negative 2. Now, over here, when you're doing division, this one kind of gets a little tricky. We obviously have this denominator, so you need to check through all your denominators, all right? And it's important that you understand that when we're doing division, that you can also write all division problems as a multiplication problem, right? So we have x cubed plus 2x squared times x squared minus 4 over x squared minus 5. So this is important because that means we have 3 different denominators. We have x cubed plus 2x squared equals 0. We have x squared minus 4 equals 0. And we have x squared minus 5 equals 0. Anything that we can represent as that denominator, so when we're dividing, we can rewrite that as multiplication, we need to make sure that either one of those values cannot be equal to 0. So in this case, I can factor out my GCF, and that's going to leave me with a x plus 2. So therefore, x equals 0 and x equals negative 2. Make this denominator 0. Here, you can go ahead and use the difference of two squares, or x squared equals 4. So therefore, x equals plus or minus 2. And it's okay if they repeat, guys. It's okay if you have multiple of them. You just need to exclude it once. And then over here, you get x squared equals 5, and you get x equals plus or minus the square root of 5. Now, that's an irrational number, okay? That's not imaginary like you have over here. So therefore, my excluded values is x cannot equal 0, plus or minus 2, and plus or minus the square root of 5. Okay, so we have a lot of excluded values here. All right, lastly, in this case, you can see that we have a couple different denominators here. We have a 4x and we have a 2x squared, and then we have this big denominator here. So we're going to have a 4x equals 0. We have a 2x squared equals 0. And then we need to set this whole expression equal to 0, because this is also a denominator in itself. Now, the nice thing here, let's kind of show my work here. The nice thing about this is obviously this is equal 0. Divide by 2, take the square root, that equals 0. And then when you here, what you're going to do is you'd multiply by 2x squared on both sides. All right, and that's just going to leave you with a 4 minus x squared equals 0. You could add the x squared to both sides, and 4 equals x squared. So therefore, x equals plus or minus 2 when you take the square root of both sides. So my excluded values here would be x cannot equal 0 and plus or minus 2. Okay, so we can see we did a lot of plus or minuses with the 2, but it's very important for you to see that, again, the 0 repeats, and that's fine. But when you're dealing with a complex fraction, that you have to go ahead and set the whole denominator equal to 0 as well when you're trying to identify those domain restrictions. Okay, so that is basically it for our notes, guys. We'll now go ahead and get into the next video, which will be actually doing the processes for simplifying rational expressions. I'll see you guys there.